All right, hey, so we're looking at a vertical launch style question at this point. Rockets launch vertically, 50 meters per second is the initial velocity. We want to know the max height and the time that it reaches the ground when it hits the ground again. Okay. So let's do this. This is a two-part question. We know that when we shoot this rocket off, here it is, and it basically goes up, and then at some point it comes to a stop. At that point, the velocity in the y direction is equal to 0. And we're going to call that a final velocity because over here, the velocity in the y direction initial was 50. Okay, and so we'll go ahead and set those two situations to be the thing, like valid or true, right? So our initial velocity y is 50. Our final velocity y is 0. This is something key. You have to know this as a physics student. And this is negative 9.8 meters per second squared. Shouldn't write so many units, it gets a bit cluttered, but there they are. And our thing we want to find is we don't want to know how long it takes or the time it takes to get to the maximum height. We want to know the actual height, and so that's a delta dy, or a change in vertical position. Okay, and there we have it. We actually have a formula that's going to give us this value very easily, plus 2g delta dy. Now, everything we have in these four situations, notice we're looking for delta dy, okay, which is this part right here, and so we're looking for that. And we have the g, we have the VFY, and we have the initial velocity y, or the initial velocity y, okay? So we've got all that stuff. All right. Now, question is, we're going to have to do a little bit of algebra, though. Hey, but that's all right. We're fine with algebra. And so I'm going to do VFY squared. I'll subtract the VIY squared, leaving a 2g delta dy. So I basically subtracted this. Maybe I'll put this in a little bit of a different color here. Pink. Basically subtracting a VIY here and subtracting a VIY here squared. These guys cancel, leaving just this guy. Now, because I'm attempting to isolate the delta dy, I'm going to divide by a 2g on both sides, 2g. And so the delta dy actually is, excuse me, VFY squared minus VIY squared over 2g. Okay? And if I plug those numbers in, looks like I'm going to get, let me calculate this out. All right, so I calculate that out. It's 50 squared, which is 2,500, divided by 2 times a negative 9.8. This stuff in here. And it turns out we get a 127.55 meters. So that's the maximum height, 127.55. Okay. Now, just to kind of remind us that this rocket, it doesn't, it's kind of like a rocket without an engine. It's almost as if it was like shot up with a spring, like somebody shot it up, and then as soon as it sort of left the launch pad, it doesn't have like a flame that's sort of making it fly more. This is maybe like a toy rocket that a kid shoots up or something like that with a slingshot or something along those lines. Because in order to qualify for projectile motion, you can't have like an engine on the thing that's flying through the air. And so we're kind of making an assumption here that this rocket has no motor. All right. So now what we have is the second part where we're trying to figure out the time that it takes to come back down. So let me erase this stuff here. Okay. Go. And now, in order to come back down, what we're going to need to do is essentially say, all right, well, now that I'm up here at the top, it falls back down, and we need to find the time. Now, we know that in a projectile motion system, we know that it's symmetrical. If it flies up into the air and then comes back down, if it comes to the same exact height, then we're a symmetrical situation. So it's kind of like goes up and then back down. The same amount of time it takes to go up is the same amount of time that it takes to come back down, again, to the same exact height. So this is not valid if we're trying to find out a different question, maybe, which we'll do later on, where you fall to a different height, maybe lower or higher than your original height. So you can't make that assumption in those circumstances, but in this one we can. So basically, what I'm going to do, excuse me, is I'm going to figure out how long it takes to go up, right? And then I'm going to double it, right? And then we'll know how long it takes to come back to the ground, okay? Well, this is a bit ambiguous, the way that I wrote this question. Are we wanting to know how long it takes to come back to the ground from the original height, or from the ground, or from the maximum height? Actually, it's a bit of an ambiguous question. On a test, I probably wouldn't count you off if you did either one of these. Anyway, let's go ahead and solve this question. So if you're looking closely at this situation, we now have, essentially, we know that it went up a certain distance. We know our initial and final velocities. We know, basically, we've got everything. So I'm going to go ahead and find the time. And to a keen eye, the easiest one would be to use the initial velocity, final velocity, and acceleration, and in order to find that time, because you know that there's the formula that says the time is equal to the final velocity minus the initial velocity over the acceleration. I went ahead and did the algebra. Remember that these two things, this actually starts over here, and the time actually starts over here. But I just did some algebra and switched them. And so now I can find my time by doing initial velocity final velocity y, 50 meters per second, minus 0 meters per second over a negative 9.8 meters per second squared, leaving us a value of about 5 seconds here, because it looks like it's 50 divided by about 10. And there we have it. Okay. Oh shoot, I actually messed this up. Give me a minute. I flipped my velocities because I got as this is 0 and this is 50. Yeah, because my initial is 50 and my final is 0. That's good because now I'm at 9 negatives cancel, leaving me about 5 seconds. Okay. think it's about 5.1 seconds. All right. That's how long it takes to get to the top. And then to get the full flight time. So the full flight time is 50 times 2, or sorry, 5 seconds times 2, looks like about 10.2 seconds. Okay, there we have it.